Hello everyone, my name is Jerry Foley with PBM. Today I'd like to speak to you about some of the innovations and solutions that PBM has come up with for the problems in the oil and gas industry as our customers have presented them to us. There are certain areas within oil and gas that present specific problems that valve manufacturers sometimes have a hard time to address. Such problems as safety, chemistry, the temperatures, pressure class, different issues that cause problems and have caused problems over the years to the process development and to the bottom line. And so what we've come up with are various solutions that, as you know, PBM being a very engineering-oriented company has developed over the years many innovative designs, and we pride ourselves on this differentiation of engineering that we can bring to the marketplace. And that's the why people, our customers, come back to us over and over again to help them solve their process solutions. As you know, we've always had a three-piece ball valve, but we also have two-piece ball valves, both of which actually incorporate our adjusted seal design. As you know, this is the design which was designed many years ago to allow with the maintaining of the valve if you have a leaky seat or a leaky body seal. By tightening up the valve, you could stop those leaks. Well, one of the more innovative uses of that concept is the concept of being able to keep the valve clean. Cleanliness in valves isn't just a sanitary thing. It is very much of a process-oriented thing, especially in such industries as oil and gas, in that those industries deal with everything from hydrocarbons to well drillings to lime mud to various kinds of solids and particulates that cause a valve to become clogged and not being able to rotate, and many times can deter the valve from operation. So what we have done, we've taken the advantage of being able to seal our valve in the upstream and downstream position to allow us to use that center cavity of the valve to clean. As an example, a standard two-piece ball valve such as this, an ANSI valve, all right, as you can see here, typical PBM two-piece ball valve has upstream and downstream sealing because, as you can see, the engineered space, this is adjustable by the body bolts. It allows the valve to be compressed and the seats to seal against the seat. But it also creates a void or a second well, if you will, around the ball, which is isolated from the flow upstream and downstream, which allows the valve to be cleaned. Now, no one else does this, but it is an answer to the problem. To show you what I mean by this, here's the same valve with two purge ports located in the body. What this allows you to do is when the valve is open, fully open, such as this, where fluid flow can go through, but you still have material entrained around the body, around the ball inside the body, you still want to be able to clean that out so that it doesn't solidify and won't allow the valve to turn. So you can come in with a purge, a steam, a fluid, whatever it might be, into the side of the valve and drain out the bottom. This is very important. Another feature that you can do with this, because you're sealing on the upstream side, you can actually, when the valve is in the closed position, you can actually have what are known as flats on the ball. Pieces cut away in the ball which allow flow past the downstream seat. That means that now with the flow stopped on the upstream seat, the downstream seat is allowed to be cleaned out by, again, purging and allowing the purging fluid to go downstream. Cleans the ball valve, cleans the piping. Very, very good in chemical process, oils, gases, anything where you might take a material and set it up. Again, don't forget, the problem is when you have a valve that's open and as you close it, the fluid is now not only going through the valve and trying to stop it, it's also in the ball and being dumped in the center body. Once it's in the center body and the valve is closed, that material can now solidify. If it solidifies, you can't turn the ball. So therefore, what is the way you clean it? As I just said, you use the purging and the idea of the sealing upstream and downstream to allow you to clean that valve. So this concept is a concept that PBM has used successfully for many years because of the basic feature in the PBM and all PBM ball valves of having those adjustable seats. So here it is in a 2-piece ANSI valve. It is available in our 3-piece valves, our 2-piece valves, our multi-port valves. It's a really good feature to talk about and to see and to understand how it works. For engineers, it's wonderful because they can finally see a way of keeping valves clean, valves operating, and what that does, it translates into a better return on your investment for the piping system you're putting in. So it's something that should be really looked at when you're looking at a new process piping layout. So this is a very good feature that is, as I say, is incorporated in all of our valves and all of our sizes. Now, the other part we talk about is safety. Safety in hydrocarbons is also very important. That's the reason in most applications and most specifications for refineries and gas plants, you'll see you must have a fire-safe valve. It may have to be a 300-pound class valve, but all of those are designed for safety to make sure that if there's a fire, the valve is shut. These valves are available as a fire-safe ball valve. Changing the Teflon seats to the seals to a graphite packing, making sure you've got a fire-safe seat inside the valve, so when the Teflon seats or whatever it might be, the primary packing is burned away, the ball valve will be pushed into a downstream seat, and you will have a nice shutoff so it will prevent the fire from being spread. So fire-safe is, again, a very important feature that valves should have in this industry. One more thing that is sort of unique to PBM, and that is safety with something as simple as a handle. One of the biggest problems that you run into in refineries and chemical plants and process plants is that most ball valves have a handle that can be turned very easily 90 degrees, and the only thing that keeps it from being knocked or hit and turned accidentally is usually just a slide collar that exists on the valve. Here it is right here. This is an old lock that PBM used to have, but everyone finds it normally. It slides up and down on the handle and locks the handle in one position. The problem is, in this position, it's just fine. If the valve is located in this position, okay, what happens? The slide lock slides down and the valve is allowed to turn. So a slide lock is very position sensitive, okay? The idea is there, but the position is very important. Now, what PBM did, they came up with something called a spring-loaded lock handle. What this does, this is a mechanism, a stainless steel spring-loaded mechanism which pushes the tang out of the way of the handle in order for it to be able to be turned. Okay, and you see it, and she locks. You can't move that handle. I can't knock it. I can't hit it. It doesn't matter if it's vertical, upside down, inside out. This is position insensitive. All right. Now this is a very good, you can lock it so that you can lock it out so that the valve can be turned anytime you want, or let it work and you've got a valve that is always locked in the position. This locking handle is available in our valves up through 4-inch. Anything above that, it would just honestly be very large and cumbersome. You couldn't actually do it unless you used a foot to push on the spring. So safety is addressed for PBM by looking at the cause, the root cause of the problem, and addressing that. Not trying to find something that is price sensitive or whatever it might be. This addresses a problem, the problem right here of the slide lock, and solves it. Okay? So that is available on all of our valves. We were also a while back, because people knew that we were doing purging and cleaning valves out. A very big problem was in their tank level sensing, where you use a typical target sensing element that measures the pressure on those elements at the high spot and low spot in the tank, and then normally sends that back to a transmitter, whatever it might be, and they look at it and they figure out what the height is in the tank. Well, the problem they had was that historically they would have a tank with a knife gate valve, and then a spool piece, and then a transmitter. Spool piece with purges on it in order to try to clean out that area, and then the transmitter. Problem was that knife gate wasn't very efficient. It would corrode, it would leak, It was very difficult to work. So we were asked, can you fellows come up with a better solution? And besides that, this valve and ring and transmitter was close to about almost 18 to 2 feet long. Very cumbersome to work with. And so the people said to us, well, you know, we need a valve, if possible, that is smaller, more compact, more efficient, turns quickly, can be cleaned, all right, and can mate up easily between the tank and our transmitter. PBM developed something called a transmitter isolation valve. This right here. This valve is in this case, is shown as a one-piece valve, all right, with an insert for the ball. It has the tank side with 2 sets of bolt mounting holes. One set is for a 150-pound flange. The other set, as you can see, they're spaced differently, is for a knife gate valve. Since that was typically, those are the 2 kinds of flanges that were typically employed, this gave people the opportunity to buy a valve that could be put in stock and used out of stock for either replacing a ball valve or a knife gate valve, okay, without having to have 2 different types of valves. That was the first thing. Second thing was it is a quarter-turn ball valve. So this is a quarter-turn ball valve that turns 90 degrees. As compared to a knife gate, which has a ratchet handle, which must be moved 90 degrees 72 times in order for it to move 3-inch. And I say 3-inch because 3-inch has typically always been the size of the connection point off a tank. Why 3-inch? Quite honestly, is because the knife gates, the minimum knife gate size was 3-inch, and that's what people always used way back. All right. So 3-inch was typically, when we first saw this, the standard size. So that's why everything was based on 3-inch. However, you didn't need a 3-inch hole. This is not a flowing valve. This is just, in effect, a garage door. It's shutting off the pressure, the fluid pressure from the tank to the transmitter. That's it. It just has to be sensed. So in liquids, we supply a valve that has a 1-inch hole, a 1-inch ball. Right? In the heavier solutions, whether it's pulp stock or hydrocarbon or whatever it might be, we use a larger ball, a 2.5-inch ball, 2.5-inch hole, so the body becomes longer, not wider, because the 2.5 will fit in here, okay? So that's the 2 sizes we have for 2 different applications, liquids and more solids or entrained solid type, thicker materials, all right? Now, remember the other problem they had, and that was that flush ring. That flush ring was used for flushing. Flushing what? Well, the problem has always been the transmitter face, because whatever was coming out of that tank was up against the transmitter face, the sensing element. That sensing element must remain flexible. If it was a heavy material, it might take a set, it might harden up, it might thicken, and what happens? The element, it can no longer flex and no longer send a signal. So, not only that, but then also, what about the valve? We know valves have to be cleaned. We already talked about that. So this valve had to be cleaned as well. Right? So what we ended up doing, just like we did here with the ANSI valve with the purge ports, we ended up putting 2 sets of purge ports in this transmitter isolation valve. One set of purge ports cleans out the internals of the valve, so that valve can always turn. Don't forget, this valve is left open until you want to calibrate the transmitter. Then you shut the valve off, take the transmitter off or whatever, and then when you put the transmitter back on or initiate the transmitter again, you have to open the valve. It is not a flowing valve, it just stays open. So if I've opened this valve and closed it once, and I've left material inside that valve, what do you think is going to happen? It's most likely going to harden up, and the valve won't be able to turn, so suddenly all you've done has been wasted. So what we did, we put the 2 purge ports in here to allow the cleaning of that ball to make sure that whenever you want to turn it, she will turn. The second set of purge ports, these 2, are used over here on this face, which is the most important face, because this takes the place of that flush ring. It is there so that when I introduce a cleaning solution, it comes through the port out here and cleans the face of the transmitter, which is sitting on this side. That's why you've got an indent here. The transmitter face sits here. So now I'm able to clean off the transmitter face and drain out that port. And then what? Then guess what? What I can do then, I can then open this valve, have the fluid come up to my transmitter, and I can actually calibrate the transmitter by just coming in that purge port with a known pressure, 3 to 15, whatever it might be, whatever the pressure might be, whatever pressure source I have to use, air, nitrogen, whatever it might be, and I can simulate the pressure of the fluid. So I can, in effect, never take the transmitter off. I can isolate the transmitter, I can clean my valve out and clean the transmitter. This was so unique for the people in the pulp and paper and power and chemistry and the chemical side. And even the hydrocarbon are now seeing this and they're saying, where has this been all of our lives? This is taking off and is doing very, very well in those positions where they need to have isolation, cleanability, and positive transmission.